Okay, now we're going to be talking about derivative rules. Now remember, the derivative is the function that gives us instantaneous velocity. And remember, instantaneous velocity, regardless of the graph, so you have a graph that looks like this, instantaneous velocity could be here, instantaneous velocity, could be here, very steep, could be here. So it's the function that produces that velocity at a given x value. Okay, so what happens when your function is y is equal to 2? Well, y is equal to 2 is a horizontal line. Well, the slope of a horizontal line is 0. So the derivative, the function that produces instantaneous velocity, so that's going to be rule number 1, the constant rule. So when you take, remember, this is the verb that tells us, this is the operator that tells us, take the derivative of the function, and the function is a constant, and there's different ways to notate it. If you've got a y, you could write dy dx. If you have f of x, you can write f prime of x. So depending on what you're given, so in this case, we would write dy dx. So dy dx, this is a constant. So imagine there's an x to the 0 right there, because x to the 0 is 1. And the power rule says you take the exponent, bring it in front of the constant, and then take that exponent, subtract 1. Well, 0 times anything is going to be 0. So the derivative of a constant is 0 every single time. Okay, now we've got the power rule. And this is what the power rule says, that if you've got x to the n comes in front times x to the n subtract 1. So we've got, here I'm telling you to take the derivative of f of x, which is 4x cubed. Now we're going to take this exponent of 3, we're going to bring it in front, times 4x to the 3 subtract 1, and then 3 times 4 is 12, 3 subtract 1, 12x squared. This is the derivative function. Now if I said find the instantaneous velocity where x is equal to 1, well, then m tangent would equal 12. If I said when x is equal to 2, well, 2 squared is 4, 4 times 12, m tangent would be 48. And think about that. If you've got 12x squared of a function, it's already a very steep, right? Well, when x is 1, so our slope is still steep, but when we put a 2 in there, we're clear up here. Look at this. That slope is very steep. All right, so that's the power rule. Let's go back up. The power rule says that the n comes in front, and then the exponent becomes n subtract 1. All right. Now what happens if you have a negative exponent? That's okay. The power rule still comes into play, where you'll have to be careful about that later for integrals, but for now, for derivatives, so here's the operator that tells us to take the derivative. That's kind of like the verb. That says take the derivative. That's the order. Take the derivative. And this time we have it as y. So when we take the derivative, we can write it dy over dx. Okay, and this negative 1, I'm going to bring down in front, which is what I did right there. times 3x, and then the exponent is that original negative 1, and now we're subtracting 1. So that's now negative 1 times 3 is negative 3, x to the negative 2, but now we have to use laws of exponents. When you've got x to a negative exponent, you rewrite it with x in the denominator with a positive exponent. So this becomes negative 3 over x squared, or the negative sign out front, just like that. And then pretty soon you'll see a pattern, and you'll be able to just look at the rational ones and very, very easily and quickly just write what the derivative is. Okay, when you're given a rational function to start off with, the easiest way to do this is to rewrite. So I'm going to put the command, take the derivative, but I'm going to rewrite, instead of in the denominator x to the positive 3, I'll put the x in the numerator, but now I have to change that to a negative 3. Laws of exponents. So that's what I did there, and there's this negative sign out front. Now I can use the power rule. So this negative 3 comes down in front, and we're going to multiply it by the negative 3x. But now that exponent is negative 3 subtract 1. And we've got negative 3 times negative 3, which is positive 9. And this x to the negative 4, using laws of exponents, gets put in the denominator. Oh, and I put f prime. I was using dy dx, so I should stay consistent. That looked, I'm sure, pretty weird. Yeah, if we're doing dy dx, just all right. So this is just another one. You can kind of see what I did. The 1/4 comes in front because that's the exponent. 1/4 times negative 4 is just negative 1. And then 1/4 subtract 1, which is subtract 4 over 4, is negative 3/4. So we'll write x to the negative 3/4 in the denominator as x to the positive 3/4. So this right here is the derivative function. And then if we said find the slope of the tangent line, where x is equal to 1, we just put a 1 in there. Well, 1 to any exponent is 1, so negative 1 divide 1. So where x is equal to 1, the slope of that tangent line is going to be negative 1. Question didn't ask for that, so I'll erase it. Okay, now all we're going to do is we're going to rewrite this as x to the 1/4 power. Because remember, roots, so square root is the same as something to the 1/2 power. So once you have it in that format, then you can use the power rule. So we have the operator that says take the derivative of f of x, which is negative 4 x to the positive 1/4. So the exponent comes in front, times negative 4x to the 1/4 subtract 1. So 1/4 times negative 4 is negative 1. I think that's almost looks exactly like we did above, x to the negative 3/4. So I end up with negative 1 over x to the positive 3/4. But because it started off showing as a root, we're going to change that. Remember, if you have x to the 3/4, this is the exponent. The numerator is the exponent. The denominator is the root. So you would rewrite this. 4 is the root. X is the 3 is the exponent. So if it starts out in radical form, you'll want your answer to be in radical form. That's just a tip when you get to college and are doing calculus, or if you're in college, that's just a tip. Okay, now what happens if we just have these letters? If you have A, B, and C, typically they're telling you that that's a number or a constant. So that could have said 5. So the first thing we're going to do is we're going to take the derivative. We're going to be told we're taking the derivative. And then now notice this b is going to come in front. And then the exponent, x to the b, becomes x to the b subtract 1. Now we don't know if b is positive or negative. If we knew that b was a negative number, then we would rewrite that as negative 3b over x to the b minus 1, like that. But we're not told if b is negative or positive. So one that looks like this, so notice again, the b came down in front like a normal exponent times negative 3x to the original exponent subtract 1. And all I did here, then the next step, b times negative 3 is negative 3b subtract 1. And I think, yeah, and then I provide, here, I'm going to leave this up here. Any of you, hopefully, I'm going to scroll through here, so anybody watching, if you want some extra practice problems, and then I'm going to show you the answer key. And then you can pause it if you want, if any of you need extra practice. And so imagine 6 is going to be similar to 5 if you were watching this and wanted to practice. This stuff right here just went, oops. I made the eraser small. Sorry about that. That just went with the other problem. 18, 20, all of this stuff right. Oh, well, I went ahead and did 20 also. So it's a constant. So we know the derivative is going to be 0. Yep, and I think that's it. And then, oh man. Oh, here's the answer key there. Right there. So for any of the evens, if any of you guys wanted practice and you wanted to check your answer, there's the answer key. All right, that's it for this one.